Hi everyone, welcome to the next session of pattern evidence reconstruction. So we were discussing about pattern evidences and we saw so many examples. So we were explaining blood stain pattern evidence in that. So blood stain pattern evidence is very important while reconstructing a crime scene because in most of the crimes like murder, rape, or any mm, assault cases, blood is a common evidence which you are encountering. So let's move on and we'll see what are the categories of blood stain patterns. So there are three categories of blood stain patterns. First one is dropping blood stain patterns, and then impacted blood stain patterns, and special blood stain configuration patterns. So dropping blood stain patterns were like formed when the blood will oozes out, or it will form like when it fell like drops. So that is dropping blood stain patterns. And impacted blood stain from a distant height, if blood is dropping to the surface, that is called dropping blood stain patterns. And impacted blood stain patterns are formed because of some external force, like if you are using a weapon like a blood weapon or sharp weapon, or like firearms or like that, high velocity, low velocity or medium velocity any weapon. If we are using an external force is we are giving, so by that this impact blood stains patterns will form. And then next one is special blood stain configuration patterns. So here when the body is like when the object is in contact with the blood stain, or there will be a transfer of objects, like transfer of blood to one surface to another surface, these special blood stain configuration patterns will occur. So it is also called transfer patterns. And for example, we can say a bloody footprint or bloody like fingerprint, like that. So these are the three categories of blood stain patterns. We'll see one by one. And first one is dropping blood stain patterns, and these patterns are produced by dropping blood found at the crime scene and are based on the biochemical and physical properties of the liquid. So the liquid blood. So there are so many physical and biochemical properties of blood is there. So, but because of that properties, when the blood, if it fall from a particular height, it will form certain dropping patterns. So we can say what are the physical properties of liquid, what are the physical properties of liquid blood. Here like surface tension is the like surface tension or viscosity, adhering property. So these are some of the physical properties, and because of that only it is giving a particular pattern. We'll see one by one. The surface tension of liquid blood causes the blood drops produced from blood source to be spherical shape, and the blood drops have a viscosity 4 times that of water, and an average volume of a drop of blood is approximately, we can say, like 0.05 to 0.6 ml, and roughly it is 20 drops in 1 milliliter under normal conditions. And when the blood is dropping, blood drop when it is released from the blood source, maybe it is finger or legs or any part of the body, if it is releasing or if it is oozing down, it will oscillate slightly during its fall. So oscillation property is also there. And then it possesses an adhesive quality, and that provides for a small amount of blood to adhere to most of the surface. So it is blood stains are adhering to most of the surface, so whether it is hard surface or soft surface or non-porous, porous surface, any surface, it is adhering to some surface because of its adhering quality. And we can say a drop of free fall blood has terminal velocity also, and it is ranging from 20 to 25, 20 to 25 feet per second. And there are so many factors which are influencing the size and shape of blood stains once it reaches a target surface. So I will show you one picture here. Here, uh, if the blood stain is falling from a particular height, we can identify the height of the from which height it fell down by seeing the shape of the uh, like blood stain. So if the diameter of the blood stains increases as the height increases, so we can say like the diameter resulting circular stain will remain constant, and it like if it is falling from a 7 feet, it will be bigger in size, and if it is falling from like 1 feet, the diameter will reduce. So from this we can identify from which height it released, uh, like from the which is the source of the uh, where was the target source of blood, and from where it released. So from this from identifying this shape of the blood stain, we can identify the height of from where it originated. And by seeing this angle of impact, like when the angle of impact is 90 degree, if it is falling from 90 degree like this, if it is falling, the blood is falling like 90 degree, it is spherical in shape. And if it is falling like this from here, again the shape will change, reduced. And if it is falling from a 70 degree, then again the shape will change. So we can say that decreasing angles, or like if the angle of impact is decreasing, or if it is an acute angle, the shape will consider like it will also reduce. And finally we can get, if it is 90 degree, we will get a shape like this. So from this is the directionality of the uh, blood stain pattern. So we from this we can identify the direction of the pattern. So this is the tail portion. So if to which direction it is traveling, that is the directionality of that particular blood stain. And we can also find out the angle of impact from by determining the measurements of the length and width of the blood stain. So we will use a formula, sine theta is equal to width by length. So see this picture here, we are calculating the angle of impact of this particular blood stain. We are measuring width and length of the particular blood stain. So when we are measuring the width and length of the blood stain, we will not measure this tail portion. We will measure only like till here. Here the width we got is 9 mm, and height is like length is 18 mm. So we are giving this to this formula, like width is 9 by 18. So we will get 0.500, and by seeing this sine theta, we will get 30-degree angle of impact. So from this we can identify from which angle that the impact has came. So the careful examination and analysis of the tail pattern will provide the information about the direction of travel and the relative traveling speed. And this this is how we calculate the angle of impact of a spherical blood stain as well as this elongated blood stain. So when we are calculating elongated blood stain, we will not take this tail portion, that you have to remember, and the formula is width by length. Sin theta is equal to width by length, and theta is equal to sin inverse width by length. So like this we can identify the angle of impact of the particular blood stain. And we there are so many examples in history for telling that blood stain pattern is an evidentiary clue, and we can confirm, we can reconstruct the whole scene of crime, whole event that occurred in the on that day by reconstructing the blood stain patterns. So we'll see one example, like once one couple couple's body were discovered in the basement of their residence, and both of them were beaten to death. And blood, so many blood patterns the investigating officer they encountered from the scene of crime, like blood dripping pattern, and then contact smear patterns, and medium velocity impact spatters, and large pooling stains were observed on the floor of that basement and from their room and all. So by studying this bloodstain pattern thoroughly, the sequence of the events was able to reconstruct. So by seeing this pattern only, they reconstructed the crime scene. And what they got is that they have their adopted son, and their adopted son breaks into the house, and first he kills his father, and by hitting with a hammer. And then he what he did is that he drags his father's body to a distant corner and covers him with a bed sheet, and he then waits for his mother to enter the basement, and he kills her with a hammer only, and carries her outside the basement. And the mother's blood drips on the top of the bloody drag mark from his father, and subsequent serological analysis identified the mother's and father's blood types and was very much helpful in the reconstructing of the whole event. So this is one case study. So you can read so many other case studies related to this blood spatter analysis and all. And this is about dropping blood patterns. So dropping blood patterns are produced by dropping blood from produced by the dropping blood, and because of their some physical and biochemical properties. And we saw what are the physical and biochemical properties, such as surface tension, viscosity, adhering quality and all. So surface tension we all know, like from uh, why a bubble, water bubble is spherical in shape, it is because of the surface tension. Like likewise only blood has its surface tension, and if it is falling from a particular distance, it is giving spherical in shape. And this kind from identifying the angle of impact, we can identify the angle of impact of the blood stain, and also the origin of the blood stain we will get from the angle of impact and the point of convergence and all such kind of things. Next we'll move on to the impacted blood stain patterns. And impact blood stain patterns, they are formed or produced with more force or energy that than gravity is referred to as impacted blood stain patterns. And this force generally comes from two sources, like external source and internal source. And the force added to the drop of blood causes the drop to break into smaller in size, and smaller size blood pattern. And these smaller drops of blood are broken into like smaller size of patterns relative to the amount of force or energy involved. So these are these force are of two types, as I told or as I said earlier, like internal or external. There then we can like we can say that point of origin of impact or bloodshed is determined by two-step process, that is determination of point of convergence, that is two-dimensional picture will get, and determination of point of origin we can identify it as like three-dimensional. So these are basic things of impact blood stain spatters. Mainly it is formed because of the external or internal force that we are applying, like energy we are giving. Like as I said earlier, like if you are using a hammer, because of the force of that hammer, this impacted blood stain patterns will come. So detail of this impact blood stains patterns we'll discuss in the next session. So thank you.